Okay, welcome back to part two. Um, Yesterday I left you with the whale fossil cards, and I had you make this chart, and I asked you to fill that chart in looking at the fossils. So I was trying to think of a way to do this. This is what I came up with. Hopefully it works. Uh, if I look at group one, which is just fossil A and M, here's what I'm looking at. And so obviously right away, you are going to see some major differences. But if I look at the similarities, what I would want you to see is that um, they're both vertebrates. So if you look, they both have a backbone. They both have four limbs. They both have a working jaw that opens and closes, and they have an eye socket. You can see the eye socket right in the middle. In terms of their differences, obviously there's a lot more differences. The shape of their jaw or the shape of their head is different. The shape of their pelvis is different. If you look, this is a little bit more thin and elongated, whereas this pelvis is more short and thicker. The nearness of the heel bones to the ground. So take a look at this animal. The foot is pretty flat, same in the front. Whereas this animal, it looks almost like it's walking on its toes and its heels are up off of the ground. Um, and then the straightness of the legs. So these are more vertical, these legs in fossil M. In fossil A, the limbs have a 45-degree, what appears to be approximately a 45-degree angle in them. So you can even say, you might have said something about the rib cages are different sizes, the length of the tail is different. You could have looked at these vertebrae on the back, where these are a lot longer and these are shorter. The length of the neck is different. M has a longer neck right here, whereas this is a shorter neck. It's hard to tell from these, but the nostrils are still in the front here. And you can kind of see it a little bit in A, that the nostrils a little bit more on top, which is slightly different. Okay. So still whales, which seems crazy because this looks more like a wolf. And what's this look like? I'm hoping you're all saying to yourself that that looks more a little bit like a crocodile. And we'll come back to that later. Okay, when you did group two, that was a little bit different. So B is really wild. I mean, look at this scale down here. I know you can't see it. I know it's blurry. I don't know why it comes out so blurry for you on your end, but that's 1 meter. So each of these lines is 1 meter. So B, which is Basilosaurus, is his name. He's so long. He's huge. He's a really, really long whale. And then D is called Durodon. So you can see his meter. He's a little bit shorter, but obviously not small. And then O, he is much shorter, but he's bigger in another way. So if you were looking at these three and looking for similarities, I would say they're all vertebrates. They'll have a backbone. They all have long tails behind their rib cage. They all have fins. You can see that their hands have turned into, they fuse, the bones have fused together, so they're more like a fin. They have jaws that open and close, and they have that flattened head that it's not rounded on top. This is slightly rounded, but for the most part, it's an elongated head. Okay, so they all have that in common. If I look at their differences, the size of their head is very different. B, much smaller head in proportion to the rest of its body. And then fins versus front legs. This looks a lot more like a fin than the other two. The other two are a little bit more, like, I don't want to say hand-like, but they're not as fused together. You can look at the number of the ribs. This rib cage is a lot larger. This one is obviously very small. The curvature of the spine, this is clearly straight, okay? This is pretty straight. This has an arc to it, Okay, this is different. I always point out too, look at these necks, guys. This neck, imagine these guys swim in water. And I don't know if you've ever carried like a bucket of water. It's very heavy. Water is very heavy. So to support the ocean water on top of your body and try and move up and down like a whale does, it would be very difficult to swim that way if your neck was this long. Okay. It would, though, indicate why you might need these really large bones on your spine to be able to support your body in that condition. Okay. And then the third row in your chart that you were supposed to do was to compare Group A from Group B. So I'm just going to put up the whole chart here. So if I were comparing Group 1 with the legs to Group 2 that did not have the legs, I would say they both have in common, they all have a head. And the head all includes, an open and closed jaw, eye sockets. They all have tails and they all have ribs. So the ribs indicate the lungs that they breathe air, as opposed to gills in a fish. The big difference between them is obviously whether or not they have legs, and then how long their tail is. And that has a lot to do with the loss of those back legs. So if you look at B, D, and O, the second group, you don't really see the back legs. Although I can tell you that B actually did have hind legs. And in the cards that I would give you in class, they're very, very faint, but you can actually see them. So let's talk about how this worked. So according to the fossil record, when we look in the layers of the rock, this is what we see. So the deepest fossils that we found were M. So the whale that looked a lot more like a whale like a wolf, is the oldest. And we found him deepest. And then we find A, the one that Ambulocetus, that looks a little bit like an alligator. So we find him, he's a little bit younger. So M has transitioned into A. So something about the environment had to change to make this alligator shape be better suited. Okay. Now here's a weird thing, and this cut it off when I put the pictures on it, but B and D are found in the same layer. So that means in the ocean at the same time, Basilosaurus and Dorodon, B and D, lived at the same time. Now, one of them probably died out, and one of them probably evolved into O, okay, which is obviously the youngest of the three. This is more like your modern day whale. So if you were to ask yourself which one disappeared, B or D, which one do you think? I hope you said B. B's body shape is just really ridiculous. It's one of those things that we find fossils of that we kind of question it. But you're going to see in the video today that Basilosaurus played a really big role in the history of the whales and how we put some pieces together. Okay, so let's take a look at the phylogenetic tree of whales. So we talked about phylogenetic trees before when we did the woolly mammoths and the elephants. And remember in the reading yesterday, we said that whales were related to your hoofed animals. So this won't let me zoom in. Oh, yes, it will. Okay. So if I'm looking at this chart, here is my hoofed land animals down below. And then those hoofed animals evolved into cows and sheep and pigs and hippopotamuses. And guess what? They all live on land. So they are all really well adapted. And it took, 65 million years to get to where they are today. But we think that there was a land animal that maybe lived close to the water, still on land. And he developed traits through mutations that made him successful near the water. And we think because he lived in a completely different environment, he evolved completely different traits. So this is the track that the modern day whales took, including card O that you had. Okay, that process took about 20 million years. That's what we see based on the fossil record. So another question you could say is there a trend in this evolutionary tree toward evolving to live in the water? And not only whales evolved from the common ancestors, You know, they're not the only thing. So it was the hooved animals. In addition, this is a different path. And the only thing that's different right here between these two is where they lived. So we're missing some of these, what we call transition fossils. And we would like to see the littler steps so we can see how M actually got to A and how A actually got to B and D. It would be kind of like a flip book, and we're missing some of the pages. You know, flip book, how you have to, or like if you do any of that stop action stuff with your phone, you can film like a stop action movie, but we're missing some of the screens. So paleontologists, people who study the remains of animals, are always looking for those intermediates, the animals that came in between. So one of my favorite videos that I show in class all year is a video called Great Transformations. And I don't show the whole thing. It's from the same PBS DVD set that the Darwin video came from. But this is all about the whales. So I want you to only watch the first 17 minutes. That's what you're responsible for. If you want to keep watching, you can. The program's probably about 45 minutes long. But the part that pertains to what we are learning is the first 17 minutes. So once it gets to 17, if you want to be done, you can shut it off. And then I want you to go into the classwork feed and take the Great Transformations exit ticket. It is 9 or 10 questions. They're multiple choice. And I am going to use it as a grade. So if you want to go back and look through that video again, you are able to do that. It's not a test. So watch the video, try and take the exit ticket. If you find that you're having trouble, either send me a message or go back and look at the video. It's only 17 minutes. You can scrub through that pretty easily and try and find your answers. And I did put the questions in order with the video, so they're not all scrambled. And like I said, send me an email and we can chat and figure something out if you are struggling. Okay? So that's all I want you to do for today. Watch that video and then take the exit ticket. And we will catch back up tomorrow to look at some analysis questions. Okay? All right, guys, enjoy the video. I'll talk to you tomorrow. Bye.